Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at graphing parabolas and also, if given certain information about the parabola, writing its equation. Let's go ahead and get started. So recall from the previous lesson that parabolas have two different transformational form equations depending on whether the parabola is vertical, which means it opens up or down, or horizontal, which means it opens left or right. And here on the notes you can see those two equations. Recall that for a vertical parabola, notice that y is on the left side and y is being raised to the first power. For horizontal parabola, x is on the left side and x is being raised to the first power. Now, in order to graph a parabola, we're going to need to identify the direction of opening, identify and plot the vertex, h, k, draw on the axis of symmetry through the vertex, identify P using the equation and use P to plot the focus and a point on the directrix. Remember, P is the distance from the vertex to the focus. Draw a line perpendicular to the axis of symmetry and through the point on the directrix to make the directrix itself. Find two additional points other than the vertex using the equation. And then finally, sketch the curve of the parabola using the vertex and the two additional points. Now, this information right here is to graph a very pinpoint accurate parabola. And to be honest, we're not going to worry about graphing a super accurate parabola. What we're going to be doing instead is, we're going to identify the direction of opening. We're going to identify and plot the vertex, h, k. We're going to go ahead and plot the focus and the directrix by finding P. And then we're going to go ahead and sketch the graph. So we're not going to really worry about finding two additional points. You did that back in Algebra 1. And we're not going to worry too much about it here. Okay, we just want sketches. We don't want, 100% accurate graphs here. So let's try a couple of examples here, starting with this example on the left. And just for the sake of time, some of the stuff I've already kind of filled in. But let's go ahead and look at the process here. So we have the parabola given by the equation y plus 3 equals 2 times x plus 3 squared. And right off the bat, I can tell this is a vertical parabola because y is the variable that we're starting with and y is being raised to the first power. The other thing that I can tell is that this parabola is going to open up. The reason I know that this is opening up is because the number outside of the parentheses here, which is where the p term can be found, it's, p is not equal to 2, but this 2 is going to help us find the p term. This is a positive number, which means p is going to be positive. And if p is positive and we have a vertical parabola, that means our parabola is going to be opening upwards. All right, next, the vertex, we can see pretty clearly here. It's going to be -3 for the x, -3 for the y. And let's go ahead and start working on finding the p term. So we know from the previous lesson that what we were going to end up doing is we're going to take this number on the outside of the parentheses here, 2, and we're going to set it equal to 1 over 4p, because 1 over 4p is coming from the equation. Now, I'm going to make this a 2 over 1 so we can do some cross multiplying. So 1 times 1 is going to equal 1, and then 2 times 4p is going to equal 8p. And we can see after dividing the 8 from both sides that p is equal to 1/8. Let's circle that because that's definitely a key piece of information. Now let's find the focus. So the focus is going to be the point h, k plus p. We know that h is -3, k is -3, p is 1/8. And this is going to give us the coordinate -3, -23/8. Now, if you're wondering where that -23/8 is coming from, basically to add -3 plus 1/8, I'm going to change the -3 into -24 over 8, getting a common denominator, and -24 over 8 plus 1 over 8 is -23 over 8. And then finally, we're going to find the directrix. Directrix is the horizontal line in this case, given by the equation y equals k minus p. That's going to tell us that y equals, well, k is -3 minus p is 1/8. And this is going to give us y equals -25/8. And again, if you're having a hard time seeing where the -25/8 is coming from, change the negative 3 into negative 24 over 8, get a common denominator of 8, then negative 24 over 8 minus 1 over 8 is negative 25 over 8. For the remainder of the notes here, for the remainder of this video rather, I'm going to go ahead and I'm not going to explain that process of combining the fractions. I'm just going to write the simplified fraction. All right, so let's go ahead and graph it now. We have all the information that we're going to need. So let's start by plotting the vertex, negative 3, 3, which is right here. Let's go ahead and plot, to the best of our ability, the focus and the directrix. So the focus, negative 3 and then comma negative 23 over 8. That's going to be roughly, it's just going to be a little bit above the vertex. And then the directrix is just going to be a little bit below the vertex. And again, we're sketching here, so we don't need a 100% accurate graph. I'm going to go ahead and say that that line right there, that's y equals negative 25 over 8. And then we know that this particular parabola is going to be opening up. So let's go ahead and... I don't like that, so let's make that a little bit better. Good enough. Again, we're sketching it. We're not giving a 100% accurate graph here. All right. In our next example, shame on me, I already have the answer graph, so let's go ahead and erase this real quick. But in our next example, let's look at graphing a horizontal parabola. So before I know that it's horizontal, notice that this is given in general conic form. So let's look at the work below real quick with completing the square to go from general conic form to its transformational form. So let's take a look at that work real quick. So keep in mind, when working with parabolas, the squared variable, which in this case is y, is going to end up moving over to the right side of the equation. And we're also going to move the negative 4y because it has a variable y as well. So these two pieces, they end up moving over to the right side. So the 3x and the 1 are going to stay here on the left. So that's how I started my problem. I have 3x plus 1 equals negative 4y squared, or negative y squared plus 4y. Notice you can't complete the square on the left because you don't have a square term. So we start the completing the square process here on the right side. I begin by factoring out the negative, because when you complete the square, the coefficient of the squared variable needs to be a positive 1. So we factor out the negative 1, we get y squared minus 4y, and then we can go and start completing the square. So half of negative 4 is negative 2. Negative 2 times negative 2 gives us positive 4. But notice that this positive 4 is being multiplied by a negative 1 that we factored out. So to balance out the equation, we put a negative 4 on this side. 3x plus 1 minus 4 is going to give us 3x minus 3. Over here on the right side, y squared minus 4y plus 4 is y minus 2 times itself. And then continuing to simplify, 3x minus 3, we can factor out the 3. We get 3 times x minus 1. Over here, the y minus 2 times itself gives us y minus 2 squared. Don't forget the negative on the outside. And then finally, to get it in the form that we really want, we divide this 3 on both sides. And we get x minus 1 equals negative 1/3 y minus 2 to the second power, which is what I have right up here. So this is what we're going to use to graph our parabola. Notice I said that this is horizontal. I know it's horizontal because x is the variable on the left that is to the first power. Also, notice that this number outside the parentheses is a negative number. This is going to tell us not only is this horizontal, but that it opens left. So let's go ahead and take note of that. Opens left. Okay. The vertex we can see pretty clearly, positive 1, positive 2. And let's go about finding the p term. So once again, we take this number on the outside of the parentheses, negative 1/3. Let's set it equal to 1/4p from the equation. And let's use some cross multiplying to solve. So negative 1 times 4p, that's negative 4p. 3 times 1, positive 3. And then divide both sides by negative 4. We get p equals negative 3/4. Or if it's easier for you to think about it, negative 0.75. All right, for the focus, for a horizontal parabola, the focus is given by h plus p comma k. this ends up being, so we know that h is, let's see, where is it? H is 1. So this is going to be 1 plus negative 3/4, so 1 minus 3/4 really, comma k. K in our case is 2. Let's see, 1 minus 3/4, that's just going to be 1/4, comma 2. So there's our focus point, 1/4, comma 2. And then finally, let's find the directrix. The directrix for a horizontal parabola like this one is given by the vertical line, x equals h minus p. This is going to give us x equals, let's see, h is 1 minus p is negative 3/4, so 1 minus negative 3/4, we get a double negative. This is really 1 plus 3/4, which means x equals 7/4. And again, this is a vertical line. So going through and drawing in these pieces here so we can sketch the graph, let's go ahead and plot our vertex 1, 2. Let's go ahead and estimate to the best of our ability the focus point. So the focus point is 1/4, 2. That's about right there. And the directrix is going to be the vertical line, x equals 7/4, which is about right there. We know this thing opens to the left. So we just sketch it in. Okay. So all in all, not too bad. A lot of pieces for us to find, but not too terribly difficult. All right. Now let's do the opposite. Let's look at some scenarios where we're going to be given a graph and maybe a little bit of extra information, and we want to write the transformational form equation. So starting with this example on the left here, a couple things that we can tell from it. First, it's definitely a vertical parabola, and we can also see that it's a vertical parabola that opens down. That's going to be important for us because that's going to tell us which equation that we're going to use to plug into. So it opens down. We can see the vertex pretty clearly. The vertex is the point -4, -1. So let's go ahead and write in that vertex, hk is -4, -1. Circle that. That's a pretty important piece of information. Now, we were given some additional information in the form of the focus. The focus is the point -4, -5/4. Now, for a vertical parabola, the focus is given by h comma k plus p. So h comma k plus p is that point -4, -5/4. Now let's think about how this is going to help us find p, because really the only thing we're missing at this point is the p term. Because if we look at the equation, this is the equation we're going to end up using. Well, we already know h and k, that's coming from the vertex. We got the equation because we know that this is a vertical parabola opening down. So all we're really missing is the p term. So let's think about it here. This -5/4 is in the position k plus p. So what that tells us is that -5/4 equals k plus p. And we know that k is -1 from the y-coordinate of the vertex. So continuing, this is telling us that -5/4 equals -1 plus p. Well, let's just go ahead and add 1 to both sides. -5/4 plus 1 is -1/4. And that gives us our value of p. And notice this should make a lot of sense because we know that if p is a negative value, we have a parabola that's opening down. Okay, so it should make a good bit of sense there. So let's plug in the pieces that we know to finally get our equation here. So let's see, y minus k. Well, we know that k is -1, so y minus -1, that's going to be y plus 1, equals 1/4 times p, p being -1/4, times x minus h to the second power. Well, h is -4, so this is x plus 4 to the second power. And now let's simplify. Y plus 1 equals, and this might look a little complicated at first, but it's actually pretty simple. 4 times -1/4 is just -1. And 1 divided by -1 is just -1. So this is just negative x plus 4 squared. All right, and there's our transformational form equation of this parabola. Y plus 1 equals negative x plus 4 squared. All right, let's look at another example, but notice in this example, we're only given the graph and we're not given any additional information. We're not going to be given the focus point to help us find the p-value. So let's kind of talk our way through what we're going to have to do here. Notice that on the graph, I've gone ahead and labeled all the clean points that I can see. These are all points that are on the parabola itself. And the goal here is going to be if we can figure out what the equation is going to look like, and if we can figure out the vertex, h and k, then we can actually solve for p by plugging in one of these clean points as an xy coordinate into x and y themselves. And that's going to leave p as the only variable left to solve, and then that's how we're going to find p and finally write the full equation. So, but let's go ahead and take note of what we have so far. One thing we know, this is definitely a horizontal parabola. We can also see that it opens right. So let's take note of that, opens to the right. All right, we can also see the vertex. We can see the vertex pretty clearly as -4, -3. Circle that because that's important. And then again, let's just kind of remind ourselves what we're going to do here. To find p, we're going to plug in a point from the graph, a point, by the way, that can't be the vertex. If you plug in the vertex, you're just going to get a bunch of zeros. So plug in a point from the graph that's not the vertex into the equation and solve for p. So the equation of a horizontal parabola is right here. What we know that h is -4, we know k is -3. So let's use any point, and me personally, I'm a big fan of using the easiest point that's available, and of the points that are available, 0, -1 is the easiest because 0 is very easy to use in calculations. So I'm going to be using the point 0, -1. Okay, so let's plug in and see what ends up happening here. Well, first let's plug in the pieces that we know. We know that h, so x minus h, that's going to be x plus 4 equals 1 over 4p. Let's see, y minus k, that's going to be y plus 3, the second power. And now let's plug in 0 for x and -1 for y, because that's one of the points that's on our graph. So 0 plus 4, plugging in 0 for x, equals 1 over 4p, -1 plus 3, plugging in -1 for y, squared. All right, let's start simplifying here. 0 plus 4 is just 4, 1 over 4p. -1 plus 3, that's just going to be, here, let's just combine a couple steps here. -1 plus 3 is 2, 2 to the second power is 4. So let's just go ahead and put a 4 right here. And then notice that 4, when multiplied to 1 over 4p, this will just turn into 4 over 4p, which is 1 over p. So we end up having 4 on the left equals 1 over p. Multiply both sides by p, you get 4p equals 1. And then finally divide both sides by 4, and you get p equals 1/4. And now we have everything that we need, because we already know the equation we're going to use. That's the equation for a horizontal parabola. We already know x and h from the vertex, and now we have p is 1/4. So let's go ahead and plug in what we know here. X minus h, again, that's going to be, get it read back, that's going to be x plus 4 equals 1 over 4, and we saw that p was 1/4, times, let's see, y plus 3 to the second power. And finally, we'll simplify. 1 over, and let's look at the bottom here, 4 times 1/4, that's just a 1. 1 over 1 is just 1. So really, all that work just to see that that outside number is just a 1. So we get x plus 4 equals y plus 3 to the second power. A little frustrating sometimes when you do all that work just to see that a whole bunch of stuff here canceled into one, but it is what it is. Okay, so let's look at some additional problems. Now we saw these problems here where we had a graph and we wanted to write the equation. Now let's look at examples where we're going to have minimal information and we need to write the equation based off of that. And what you're going to notice is that for both of these problems, I think the best approach usually is to do a quick sketch to kind of get a visual of what's going on and then see what kind of information you can get from that sketch. But in this first problem, we're going to want to find the transformational form equation of the parabola if all we're given is the vertex is 5, -10, and the directrix is the horizontal line y equals -41/4, which if you look at it as a decimal, it's a little easier to think of as a decimal, the horizontal line y equals -10.25. So I made a quick sketch here. Here's my vertex, 5, -10. Here's my directrix, the line y equals -10.25. Notice that the directrix is just barely below the vertex here, but this actually gives us a lot of information. First off, we know that parabolas open away from the directrix. So we know this parabola is going to open up. And that's going to automatically give us the formula that we're going to end up using. So let's think about some of the other things that we can tell. Well, first off, we already know the vertex. The vertex is, get the right color here. The vertex here is 5, -10. Okay, the directrix, y equals k minus p. Well, the directrix was y equals -41/4. And let's think about how this is going to help us. Very similar to kind of what we did in one of the previous problems, we can look at this and say, okay, well, if the directrix is y equals -41/4, and we know that for a vertical parabola, the directrix is the horizontal line y equals k minus p, and that means -41/4 has to equal k minus p. So I can set up a little equation here. I can say, all right, well, -41/4 equals k minus p, but we already know that k is -10. So now we can substitute that in. -41/4 equals -10 minus p, and now we have a very simple equation here that can allow us to solve for p. So let's add 10 to both sides. -41/4 plus 10 is going to be -1/4. So -1/4 equals -p. Multiply both sides by -1, or divide both sides by -1, same thing. And you get that p is equal to 1/4. All right, but one thing that I want you to notice is that p, if you're on top of your definitions, if you're on top of what these variables represent, p is just the distance from the vertex to the directrix. So if you were really looking here, if you were looking at this and saying, I understand, here's my directrix, here's my vertex, and I understand that p is the distance between them, then you could have very quickly looked at this and said, okay, well, here's -10, here's -10.25, the distance between the two is just 0.25 or 1/4, and that would have got you the value of 1/4 right there without really having to do this work. But this is kind of the mathematics behind it that kind of backs that up, okay? So p equals 1/4, we know the vertex is 5, -10, we know it's a parabola opening up. That gives us everything we need. We can go and write the equation. So the equation for a vertical parabola is right here. Let's go ahead and plug in the pieces and simplify. Y minus k, that's going to be y plus 10, equals 1/4p. We know p, by the way, is 1/4, times x minus h squared. That's going to be x minus 5 squared. And then now let's simplify, and we're done. This gives us y plus 10. We can see here, 4 times 1/4, that's just 1. 1/1 is just 1. So we just get x minus 5 squared. Y plus 10 equals x minus 5 squared. All right, it's pretty cool. Let's try one more problem to wrap up the notes here. And this time we're gonna want to write the transformational form equation of the parabola given the focus and the directrix this time. And I've gone ahead and converted some of these fractions into decimals just because it's a little easier to think about what the graph is going to look like. So I converted the focus to the point -7.5, -2, and the directrix to the vertical line, x equals -6.5. And once again, I did a very quick sketch here. Here's our point, the focus, -7.5, -2, and this red vertical line is the directrix, -6.5. So a couple things that this tells us. Number one, we know that the parabola opens away from the directrix. So we know the parabola is going to be opening to the left. This is the first thing this quick sketch is going to tell us. And again, once we know that it opens to the left, we know the equation that we're going to end up using. But it also tells us the vertex, because keep in mind, the vertex is going to be located halfway between the focus and the directrix. So if the focus is at -7.5, -2, and the directrix is the line x equals -6.5, well, halfway between -7.5 and -6.5 is going to be -7. So we can see that the vertex is the point -7, and then it's going to have the same y value as the focus here, so -7, -2. So pretty cool little result there. Now, instead of going through all the math like we did up here to find the value of p, let's kind of common sense our way through this here. We know that p is the distance from the vertex to the focus, or the vertex to the directrix, doesn't matter. And if the vertex is -7, -2, so let's say that'd be a point right here, right? -7, -2. Well, the vertex is -7, -2, and the focus is -7.5, -2. Well, then p is just going to be -1/2. And be very careful about, it's important to understand why I'm saying it's -1/2. We can see that 1/2 is the distance from the vertex to the focus point, but it has to be negative because this parabola is opening left. Okay, we talked about p kind of determines, or p is how you can determine the direction of opening. We know this thing is opening left, so we know that p has to be a negative value. So p in this case is -1/2. But now we have everything that we need, so let's go ahead and plug the pieces in. All right, x minus h. Let me get the right color here. There we go. All right, x minus h, that's just going to be x plus 7 equals 1 over 4p. We know that p is -1/2 times y minus k squared, that's just y plus 2 squared. And then finally, simplifying fully, 4 times -1/2, this is just -2. So we're going to have -1/2 y plus 2 squared.